Okay, I'm going to do one more word problem for systems of linear equations today. Once again, I'm going to take it from my textbook from this year, which is Houghton, Mifflin, Harcourt, the Go Math. So here is the problem. It says 8 friends started a business. They will wear either a baseball cap or a shirt imprinted with their logo while working. They want to spend exactly $36 on the shirts and caps. Shirts cost $6 each, caps cost $3 each. Once again, this particular word problem tells us to which variables should stand for what. This one says let x represent the number of shirts and let y represent the number of caps. If the word problem doesn't tell you that, you have to decide that on your own and make sure that you stick with that throughout the word problem. Okay? So because they did that, they set up the graph for us, and they have, since x is shirts, they've got the x-axis labeled with shirts, and since y is caps, they've got the y-axis labeled with caps. Okay? If you were doing this word problem completely on your own, then you'd have to set up the graph and label it correctly. Okay, so let's start this one. X is the number of shirts. And y is the number of caps. Okay? We have to come up with two equations, and the majority of the time these word problems are asking you for a how much and then quantity. So one's quantity, one's price, something like that. And we know right here from the word problem that 8 friends started a business. So because 8 friends started a business and they all have to wear either a cap or a shirt, that's our quantity of items. So we're going to have x plus y equals 8 as one of our equations. Okay? But now we also know from the word problem that they want to spend exactly $36, that shirts are $6, and that caps are $3. So we need a money equation now. So if shirts are $6, we're going to say $6 per shirt plus caps were $3, $3 per cap, and they are only going to spend $36. So we have one equation that represents the quantity of the items, and then another equation that represents the money. Okay? We have to graph these, and similar to the last problem, these are not in slope-intercept form, so let's put them in slope-intercept form. Okay. Subtract my x from both sides, and I have y equals negative x plus 8 as my first equation. All right, let's graph that one. My intercept is 8. Let me just check this graph really quick. It looks like this graph is going by 2, so I have to be very careful when I do my slope. So if my slope is negative 1 over 1, and my graph is going by 2's, I'm going to keep this equivalent and just make it go negative 2 over 2 so that I don't make a mistake plotting my points. So I'm going to go down 2 over 2 because this graph is going by 2's, okay? Down 2 over 2. Take my protractor and draw the line. First line drawn. Okay, this is my second equation, and I need to put it in slope-intercept form. 6x plus 3y equals 36. The x is on the wrong side of the equal sign, so I'm going to subtract it from both sides of the equation. Negative 6x plus 36. Y has to be alone. Y equals mx plus b. Y is a singular y, quantity of 1. So I need to divide off this 3. Divide it from the entire right side of the equation. Okay. This is a 1y now. So 1y equals, this becomes negative 6x over 3. This becomes plus 36 over 3. Now we simplify. Negative 6 divided by 3 is negative 2. 36 divided by 3 is 12. And so there is our new equation. It is equivalent to the original, just in a different format. And I need to graph this one. Can I get all that on the camera? Let me go like this instead. Okay, my intercept is 12. My slope is negative 2. So that would be negative 2 over 1. Okay. That means a rise of negative 2, a run of 1. Going down 2 and over 1 would only be halfway here. Got to be really careful, okay? Down 2 over 1, 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 down to over 1. This one's kind of hard to see because I'm plotting points so close to the other ones. Let me get this drawn correctly. Okay. And now you can see that the point of intersection, where they intersect, is 4, 4. Okay. So, what does the solution represent? The solution, because the x-axis is shirts, and this is a 4. The y-axis is caps, and this is a 4. We have 4 shirts and 4 caps. Right.